Okay, in this video we're going to be talking about coterminal angles. Okay, so from here on out you're going to have to be using reference angles to find what sine, cosine, and theta, or sine, cosine, and tangent are going to equal. So first we're going to talk about where they sit in the quadrants and how to find a reference angle. So a reference angle is basically the acute angle that you can make a triangle out of using your terminal side, so using that x-axis. Okay, so quadrant 1. If I made my triangle here, it's just going to represent theta. Okay, so that is going to be my answer down there. So my reference angle, so this little theta with a line means reference angle is going to be whatever that degrees is. So if it was 30, it'd be 30 degrees. Okay, if I was sitting in quadrant 2, so this would make my angle, but for all of these I need to make a triangle. Okay, so to get my reference angle, if that's my angle, I have to make a triangle. That is what I'm going to want. Okay, so in this situation, I have to do 180 minus whatever that degrees is to make whatever is left my triangle. Okay, quadrant 3, so it would be sitting in here. So normally this would make your angle to make it in quadrant 3, but to make my reference triangle in this one, all I really need is what's left right here. So I need to take away this 180 from the degrees. Okay, so this time I do 180 minus the degrees, or the degrees minus 180. My apologies. Degrees, because you're taking away that 180 degrees that you don't want. Okay, here if it sits in your 4th quadrant, normally it goes all the way around. But to make that reference triangle so that he sits on the x-axis here, I really just want this. So this time you do 360 minus your degrees to figure out what's left. Okay, so all of your reference angles, their butts are always going to be touching the x-axis. So we have our hypotenuse, which is technically my radius in my circle, which will always be positive. And then we will make all of our reference angles based on that. So those are your 4 reference angles in your 4 different quadrants that you will be making. Okay. Sketch the angle and then find its reference angle. So 330 is going to sit down here. So normally you would go all the way around, but to make my triangle, I don't really care about that 330. I want what's left of it. So I need to do 360 minus 330 to get that little chunk that I want left. So my reference angle in this is going to be 30 degrees. We're going to convert this one to degrees, so I need to get rid of the pi's. That's why I stuck my pi on bottom. So I got negative 150. So if I draw my negative 150, he's going to be sitting here, so it would normally look like this. We make our reference triangle with his butt up against the x-axis. So I really want this. So if I do 180 minus that 150, I'll get my 30 degrees that I want left, and my reference angles will always be positive. Okay, my next one is 135, so I know I go 0, 90, a little less than 180, so here it is. I'm going to make my triangle in here. So I know that I have 135. I know all the way around is 180, so I got to do 180 minus 135. To get my reference angle in here, which is 45. Okay, 200. I go 0, 90, 180. The next one's 270. So this would be my reference or all the way around. So if I make my triangle in here, I want to get rid of 180 of it and get that little tiny portion that's left. So 20 is going to be my reference angle. And all of these should be acute angles, so they should all be less than 90 and positive. Okay, my next one here, we got to multiply by 180 over pi. My pi's will cancel. So I got 300. So he's going to be sitting in that quadrant, so we're going to make our reference triangle. Okay, all the way around is 360. I don't care about 300 of it. I want what's left of it. So 360 minus 300 my reference angle is going to be 60 in this one. Okay, multiply by 180 over pi. We get 60. Should be sitting in the first quadrant, which automatically makes my triangle, so 60 will be your reference angle in that one. Okay, so in a 30, 60, 90, remember across from 30 is x, across from 60 is x square root 3, across from your right angle is always 2x. I'm going to draw it twice because we're going to look at it from the 30 and the 60. Okay, so across from 60 is x square root 3, 2x, and x, and then my 45, 45, 90, x square root 2. Okay, so my first one's, okay, we're looking at it being in quadrant 1, so we're trying to decide if it's positive or negative. Okay, we're actually not going to use the reference triangle, so we're just going to go straight into this. Okay, so quadrant 1, I go quadrant 1, 2, 3, 4. You don't need to memorize this. I'll show you guys a shortcut so you don't have to memorize this. Okay, so if I'm in quadrant 1, if I go right, it is going to be positive. My radius or my hypotenuse will always be positive, and then up is positive. So if I'm doing, if I'm looking at it from my theta, I've got my opposite, my hypotenuse, and my adjacent here. So if I fill in my SOHCAHTOA, sine is O then A, so my O is positive, my A is positive, positive divided by positive is positive. Okay, my cosine is A then H, so positive over positive, which is positive. Tangent is O then A, so positive over positive. Okay, so anytime I do sine of any degree or cosine of any degree or tangent of any degree, my answer will be positive. Okay, if we move to quadrant 2, left is going to be negative, up is still positive, and my radius is always positive. We're going to fill in our O's and A's. So opposite, hypotenuse, adjacent. So sine is O then H, so positive over positive, which is going to be positive. Cosine is A then H, so negative over positive. Negative divided by positive is a negative. Tangent is O then A, so positive over negative, which will be a negative. Okay, so my answer for a sine will always be positive. Cosine of any degree will always be negative. Tangent of any degree will be negative. And then I'm going to go ahead and fill in. So my quadrant 3 here, my x will still be negative. Down will be negative this time, and my hypotenuse will be positive. Quadrant 4, my x will still be positive. Down is negative, and my hypotenuse will be positive again. I'm going to go ahead and fill in the rest of your pluses and minuses here so that we can move to the next part. Okay, so I'm going to leave this off. I'm going to figure out what quadrant it's sitting in. So sine of 135 sits out here. So it's going to be in quadrant 2. Its reference angle, so to make that a triangle here, I need to take away that 135 from 180, and I get 45. So if I redraw him so I can actually see it, it is a 45, 45, 90, so I'm going to go ahead and label. So if I go left, it's a negative x, up should be positive x, and then this should be a positive x square root 2 because it's the radius or the hypotenuse. Okay, then I go back up, I can figure out my sine, cosine, tangent. So if I go ahead and label, this is my opposite, my adjacent, and my hypotenuse. So it says sine. So sine in my SOHCAHTOA is O over H. So my O is x. Oh, my reference angle was 45. And then my h is x square root 2. So if I simplify that, it will get me square root of 2 over 2. Okay, tangent of 300. It's going to be sitting down here. So to make my triangle like this, I do 360 minus that 300. So my reference angle in there is going to be 60. sitting in quadrant 4. So it's going to be a 30, 60, 90. So across from my 60 is always x square root 3, and since it's going down, it's a negative x square root 3. Across from my right angle is 2x, and since it's my hypotenuse and my radius, it will be positive. Across from my 30 is x. Then we're going to label, we've got my opposite, my hypotenuse, my adjacent. We're doing tangent, so it should be O then A. So my O, and then my A. Okay, to check your answer, if you make sure your calculator is in degree mode, you can type in tangent of 300 and it should pop out that answer for you. Okay, my next one, we need to multiply by 180 over pi to figure out the actual degree. Which is 420. Take away that one rotation, that 360, and it's going to be 60 degrees. So it's going to sit in quadrant 1. It's going to be that reference angle, or that 60 for me. I'm going to redo this. Okay, across from my 60 is x square root 3. Across from my right angle is 2x. And then across from my 30 is x. All of them should be positive because they're going up and right. If I go ahead and label my O's and A's, I've got opposite, adjacent, hypotenuse, and we are doing cosine, so I need my A, then my H, which will simplify to 1/2. Okay, you could type in cosine of 420 and it should pop out that 1/2 for you, or you could change your calculator to radian mode and type it in with the radian. Okay, find the exact values of the three trig functions. So this is going to be my x value, this is going to be my y value. So positive 8 means I'm going right 8. A negative 15 for my y means I need to go down negative 15. Okay, so there's my right angle, there's my theta. I got to use Pythagorean theorem to find that missing side. So that's my c. So I got 8 squared plus negative 15 squared equals c squared. We're squaring that whole side, so if you just want to put a positive 15 in here to make sure your side is positive, that's fine. Okay, and then opposite of squaring is square rooting, so you could type that whole thing in your calculator so that we can find our c. And I'm getting the square root of 161 here. Okay, so if I label my sides, I've got my opposite, my adjacent, and my hypotenuse. So my sine is O then H, so negative 15 over the square root of 161. Just kidding, I did my math wrong. That was the square root of 289, which gives me 17. Let's put a little 17 in there. Okay, so SOHCAHTOA, I go O then H, so negative 15 is my O, my H is 17. Cosine is A then H, so A then my H. Tangent is O then A, so negative 15 over 8. Okay, my next one, it's negative 3 then 12. So it's my x, my y, so negative 3, positive 12. There's my right angle, so I know I have my opposite and my adjacent. I need to find that hypotenuse, so 12 squared plus 3 squared equals c squared. So that's what we're square rooting this time. So the square root of 153. Okay, so that's my hypotenuse. So I do my O, then my H, which simplifies to 3 square root 17. Okay, so my O is 12, my H is 3 square root 17. So if I type it in my calculator to simplify it, I would get 4 square root 17 over 17. Okay, my cosine is A then H, so negative 3 over 3 square root 17, which if I type in my calculator will simplify square root of 17 over 17 negative. Tangent is O then A, so 12 over negative 3, which is negative 4. Okay, my last thing tells me what quadrant. So if I remember my SOHCAHTOA here, cosine is A than h. It sits in quadrant 3, so I know it sits down here. My hypotenuse can never be negative, so we're going to put him as a positive 5. That makes my a negative. Okay, here's my right angle. I have to use Pythagorean theorem again, so I got negative 3 squared plus b squared equals 5 squared. And then if I solve this, I should get my b to equal 4, but since it's going down, it needs to be a negative 4. Okay, and then I need to find my sine of theta and my tangent of theta. So if I label my opposite, my adjacent, and my hypotenuse, sine is O then h, so negative 4 over 5. Tangent is O then a, so negative 4 over negative 3, so positive 4 over positive 3. Okay, my next one, sine is O over h. It's between 90 and 180. So he's going to be sitting out here between 90 and 180. My hypotenuse is 5. My opposite is 4. So I know that bottom one's going to be negative. So I'm going to have to do 5 squared minus 4 squared and square root it to find him. And he's going to be a negative 3. Okay, if I label my sides again, I have opposite, hypotenuse, adjacent. Cosine is a then h, so negative 3 over 5. Tangent is O then a, so 4 over negative 3. Okay, my last one is in quadrant 4. So it's opposite over adjacent. So my opposite I know is 12. My adjacent I know is 5. The 5 needs to be positive. The 12 needs to be negative because it's going down. So I need to do 5 squared plus 12 squared equals c squared to figure out, and then I square root both sides. So I'm going to get 13. I'm going to label opposite, adjacent, hypotenuse. So my sine of theta, my cosine of theta. So my sine of theta is opposite over hypotenuse, so negative 12 over 13, and cosine is adjacent over hypotenuse, so 5 over 13.